Hello there, and welcome to the Sleepy Nature Channel. Find yourself a comfortable place. Maybe you're already there, tucked in, the room just the right temperature, the world outside going quiet. Take a slow breath in and let it out even more slowly. There's nowhere to be right now, nothing to do, just this soft, warm voice, and a story about one of the most ancient, remarkable things on this earth. Tonight, we're going to travel deep, deeper than rivers, deeper than roots, deeper than anything you've ever walked on. We're going to learn about volcanoes, not the loud, dramatic volcanoes you might imagine from movies. No. We're going to find the quiet truth inside them, the slow, patient, almost tender way the earth breathes and shifts and eventually gently releases. Because volcanoes, when you really understand them, are less like explosions and more like sighs. Long, slow sighs from a planet that has been holding something warm for a very, very long time. So, settle in. Let your shoulders drop. Let your hands rest where they are. And let's begin at the very beginning, at the heart of the world itself. Beneath your feet, right now, the earth is warm. Not just a little warm, extraordinarily, beautifully warm. The center of our planet sits at around 5,000 degrees Celsius, which is about as hot as the surface of the sun. Isn't that something to sit with? The sun-like heat right beneath you, sleeping under layers of rock and time. This heat has been there since the very beginning, when the earth was born about 4.5 billion years ago. It was formed from clouds of dust and gas that slowly pulled together, colliding, compressing, warming. All that collision created heat, and that heat, incredibly, never fully left. It's still there, still glowing gently in the deep dark of the planet's core. The earth has layers like an onion, or like the rings inside a very old tree. At the center is the inner core, solid, dense, mostly iron and nickel, pressed together so tightly by the weight of everything above it that even at its tremendous heat, it cannot melt. It simply holds. Quietly, steadily, it holds. Surrounding that inner core is the outer core, which is liquid. Liquid iron and nickel, slowly swirling in the dark, generating the magnetic field that wraps around our whole planet like an invisible blanket. The same field that guides birds on their migrations and makes compass needles turn. Above that is the mantle. The mantle is enormous. It makes up about 84% of the Earth's total volume. It's made of rock. But here's something that might surprise you. This rock, under the right conditions, can flow. Not quickly, not like water, more like honey left in a cold room. Over thousands and millions of years, the rock of the mantle moves, creeps, circulates, rising where it's hotter, sinking where it's cooler, in great slow loops that take millions of years to complete. Scientists call this convection, but you can simply think of it as the earth breathing, slowly, deeply, in its own time. This flowing rock in the mantle is called magma, and magma is in many ways the main character of our story tonight. Magma is molten rock, rich in minerals and dissolved gases, warm and patient, moving through the deep earth like a slow river beneath a river. It doesn't rush. It has nowhere urgent to be. It simply follows the paths that pressure and heat and time have opened for it. The very top layer of the earth, the part we live on, the part that holds our mountains and oceans and forests and cities, is called the crust. The crust is thin, relatively speaking. Under the oceans, it might be only 5 to 10 kilometers thick. Under continents, perhaps 30 to 50 kilometers. Compared to the vast depth of the mantle below, the crust is like the skin on a warm bowl of soup, thin, a little fragile, floating. And this crust is not one solid piece. This is one of the most wonderful things about our planet. The crust is broken into enormous sections called tectonic plates, about a dozen major ones and several smaller ones. These plates fit together something like a puzzle, and they are always moving. You can't feel it. It's far too slow. But right now, the ground beneath you is drifting ever so gently at roughly the same speed your fingernails grow. These plates float on top of the slow-moving mantle below, carried along by those deep convection currents. The Earth's long, slow breathing, and wherever plates meet, interesting things happen. They might pull apart from each other, creating gaps. They might push into each other, crumpling up into mountains. Or one might slide beneath the other in a process called subduction. One plate diving slowly downward back into the warm mantle below. It's at these places, these edges, these boundaries, these meeting points, that most of the world's volcanoes are born. Volcanoes are, in their way, the Earth's release points, the places where the long, patient pressure of the deep world finally finds a way to the surface. Take a slow breath now. You're doing so well, just resting here. If you're enjoying this story, feel free to leave a like. It helps more sleepy listeners find their way here. And there are more stories just like this one waiting for you in the playlist. The most famous gathering of volcanoes on Earth follows the edges of the Pacific Ocean, a great curving ring of tectonic activity that stretches from New Zealand up through Japan, across to Alaska, and down along the western coasts of the Americas. It's called the Ring of Fire, though tonight we might prefer to call it the Ring of Warmth. About 90% of the world's earthquakes happen along this ring, and roughly 75% of all active volcanoes. But volcanoes aren't only found at plate edges. Some sit in the middle of plates, far from any boundary. These are born above what scientists call hotspots, places where an unusually warm plume of magma rises from deep in the mantle, like a slow candle flame burning up through the rock. The Hawaiian Islands were made this way. Each island, a mountain of cooled lava that rose from the sea floor over millions of years, built up layer by layer until it finally broke the surface of the ocean and became land. Think of that. The island you might walk on in Hawaii. The soft black sand beaches, the palm trees, the warm air. All of it was once deep beneath the earth, liquid and glowing. Over time it rose, cooled, hardened, and became a place where flowers grow and birds sing and people watch the sunset. Every volcano begins as a place where magma is collecting, deep underground in a chamber or a network of connected spaces in the rock. Magma gathers. It pools slowly, building up over years, decades, centuries, sometimes much longer. The rock around it bends and adjusts and accommodates. The magma waits, and in that waiting, something is building. Not tension, not danger, just pressure. The quiet, inevitable pressure of heat and depth. Magma contains dissolved gases, mostly water vapor, but also carbon dioxide, sulfur dioxide, and others. These gases want to expand. At great depth, the pressure of all that rock above keeps them dissolved, locked inside the magma, like the bubbles in a sealed bottle of sparkling water. But as magma begins to rise, drawn upward through cracks and channels in the rock, following the path of least resistance, the pressure decreases. And as it decreases, those dissolved gases begin to come out of solution. Bubbles form, and bubbles in magma create buoyancy. They make the magma lighter, and lighter things rise. It's a slow and beautiful process, like watching a soap bubble form on the surface of warm water. Patient, inevitable, gentle in its own deep way. Let your breath slow a little more. Let the images drift through your mind. The deep glowing chambers, the slow rivers of warm rock, the ancient patient heat of the world beneath you. You are resting on top of something wonderfully alive. The magma rises slowly through the Earth's crust, following channels called conduits, natural pathways in the rock, sometimes narrow, sometimes wider, shaped over thousands of years of the Earth's own quiet rearranging. Imagine water finding its way through soil after a gentle rain. It doesn't force anything. It simply finds the openings, the soft places, the paths that are already waiting. These conduits lead toward the surface, and at the top of many volcanoes there is a crater, a bowl-shaped opening, sometimes small, sometimes wide and deep. And at the bottom of that crater, the vent. The vent is the final doorway, the place where the deep world and the surface world meet. Not all magma makes it to the surface. Sometimes it cools and hardens inside the earth, forming great masses of rock deep underground. These are called plutons, and they sit in the dark for millions of years until, slowly, erosion strips away the rock above them, and they emerge as mountains or rounded hilltops. The beautiful granite domes of Yosemite, those smooth, enormous curves of pale rock, were once magma hardened underground, patient through all the ages until the surface finally came to meet them. The word volcano itself comes from Vulcan, the Roman god of fire, of the forge, of crafting things with heat. The Romans named a small island off the coast of Sicily after him, Volcano, because it smoked and rumbled, and they believed the fires beneath were the forge where Vulcan made weapons for the gods. The name traveled through centuries and became the word we use today. Something ancient and mythological still lives quietly inside that word. There are different kinds of magma, and they behave quite differently from each other. The differences come mostly from silica content, silica being a compound of silicon and oxygen that affects how thick, how sticky, how viscous the magma is. High silica magma is thick and sluggish, like cold peanut butter. Low silica magma is much more fluid, closer to warm syrup. These two types create very different kinds of volcanoes and very different kinds of eruptions. The fluid, low silica magma is what flows in Hawaii. Because it's so runny, the gases escape relatively easily, and the lava, that's what we call magma once it reaches the surface, flows out in long, slow streams. These are called effusive eruptions, gentle in their way. Lava flowing down a hillside at walking pace, cooling as it goes, forming new land at the edge of the ocean with a soft hiss of steam. The thick, high silica magma behaves differently. The gases can't escape as easily because the magma is too viscous, too sticky. The pressure builds more intensely before finally finding release. These eruptions tend to be more explosive, sending ash and rock fragments high into the sky. But even these, viewed from a safe and scientific distance, have their own strange beauty. The columns of ash rising in great cauliflower clouds, the sky painted in purple and amber at sunset by the tiny particles drifting through the atmosphere. In fact, volcanic eruptions throughout history have created some of the most extraordinary sunsets the world has ever seen. When Krakatoa erupted in 1883, the fine ash it sent into the upper atmosphere spread around the entire Earth and created vivid red and orange sunsets visible from Europe to North America for months afterward. Artists painted those skies. People wrote about them in letters and diaries, describing colors they had never seen before and might never see again. Let your eyelids grow a little heavier now. You're doing beautifully. Just resting, listening. If this is helping you drift off peacefully, you might enjoy the other stories waiting for you in our playlist: forests, oceans, rain, stars. They'll be there whenever you need them. There are roughly 1,500 potentially active volcanoes on Earth. Volcanoes that have erupted in the last 10,000 years or could erupt again. About 500 of those have erupted in recorded human history. Right now, at any given moment, around 20 to 30 volcanoes are erupting somewhere on Earth. Most of them quietly, gently, with slow lava flows or gentle emissions of steam and gas. The most active volcano on Earth's surface is Kilauea on the Big Island of Hawaii. It has been erupting more or less continuously since 1983. Over 40 years of slow, patient lava flows, adding new land to the island bit by bit. Scientists visit it regularly. They walk the hardened lava fields in heat-resistant boots, collecting samples, watching the slow orange glow at the edges of active flows. It is a place that feels like the beginning of the world. Underwater, the activity is even greater. The longest mountain range on Earth is entirely beneath the ocean. The mid-ocean ridge system, stretching some 65,000 kilometers around the globe, like the seam on a tennis ball. Along this ridge, tectonic plates are slowly pulling apart, and magma rises up to fill the gap, cooling into new seafloor. This process, seafloor spreading, creates new ocean crust constantly, quietly, in the dark depths where sunlight never reaches. Near these underwater vents, something remarkable happens. Even in water that reaches temperatures far above what we normally think of as the boiling point, kept liquid only by the immense pressure of the deep ocean, life exists. Entire ecosystems cluster around hydrothermal vents, communities of tube worms and shrimp and bacteria that live not on sunlight, as nearly all life on Earth's surface does, but on chemical energy from the Earth itself. Life finding warmth. Life finding a way. The gases that volcanoes release have shaped our atmosphere over billions of years. In the very early Earth, before life as we know it existed, volcanoes were the primary source of the water vapor, carbon dioxide, nitrogen, and other gases that formed our earliest atmosphere and eventually our oceans. The water you drink, the air you breathe. Part of their ancient history involves volcanoes, slow and steady, breathing out the building blocks of the world we live in. Let that thought drift through you gently. The very air around you right now, so soft and quiet in this room, has a history that stretches back billions of years. You are breathing something ancient and wonderfully made. Volcanoes on other planets remind us just how universal this process is. Mars has Olympus Mons, the largest known volcano in the solar system. It rises about 22 kilometers above the surrounding plains and spans nearly 600 kilometers across. If you stood at its base, you couldn't see the summit. It would be beyond the curve of the horizon. It is so vast that you would need to be far out in space to appreciate its shape. And yet, it formed the same way. Magma rising, layer upon layer, over billions of years of slow, patient building. Venus, too, is covered in volcanoes. Scientists believe it may still be volcanically active today. The thick, hot, dense atmosphere of Venus was likely shaped in large part by volcanic outgassing over billions of years. Even the moons of other planets, Io, a moon of Jupiter, are intensely volcanic, covered in active eruptions, glowing with orange and yellow sulfurous flows in the cold of space. We are not unusual. We are part of a universe that builds and releases, builds and releases. A universe that breathes. There's a particular kind of volcanic structure called a shield volcano, and the name is very fitting. From above, it looks like a warrior's shield lying flat on the ground. Wide, gently sloping, low and broad, rather than tall and pointed. Shield volcanoes form when fluid lava flows easily in all directions over many eruptions, building up layers that spread outward rather than piling steeply upward. Mauna Loa in Hawaii is a shield volcano, and measured from its base on the ocean floor, it is the largest volcano on Earth by volume, even larger than Olympus Mons, though it doesn't rise as high above its surrounding landscape. The thought of that hidden bulk beneath the ocean, this vast mountain sitting patient and enormous in the deep water, has something deeply peaceful about it. All that size, all that quiet, all that slow accumulated warmth. Stratovolcanoes sometimes called composite volcanoes, are the tall, cone-shaped mountains that most people picture when they think of a volcano. Mount Fuji in Japan, Mount Rainier in Washington State, Mount Etna in Sicily. These are built from alternating layers of ash and lava, each eruption adding another stratum, another ring of history, like the rings of a tree, recording the passage of years and seasons in the language of rock. Mount Fuji is so perfectly symmetrical that it has been called one of the most beautiful mountains in the world for centuries. It appears in thousands of woodblock prints, poems, songs. In winter, it wears a cap of snow. Pilgrims have climbed it since ancient times. And beneath that perfect, peaceful silhouette, the same deep processes are resting. The magma chamber, the conduit, the long memory of the earth. Let yourself rest a little more deeply now. Feel the weight of your body against whatever you're lying on. The world is very quiet at this hour, very still. And underneath all that stillness, something warm and ancient is resting too. Cinder cone volcanoes are the smallest and simplest type. Steep, conical hills made almost entirely of loose fragments of lava called cinders or scoria that were thrown into the air during eruption and fell back around the vent. They tend to form quickly in geological terms. Some have formed in just a few years. One of the most famous, Pericotin in Mexico, began as a crack in a farmer's cornfield in 1943 and grew into a mountain over 200 meters tall within a year. The farmer, Dionisio Pulido, actually witnessed the very first moments of its birth. Smoke rising from the earth, the ground swelling and cracking, the first glowing fragments being thrown skyward. He described it with a kind of awe that must have been overwhelming. The earth opening and making something new right in front of him. The rock that forms from cooled lava has many different textures and personalities. Pahoho lava, the Hawaiian word, pronounced pa-hoi-hoi, cools into smooth, ropey, folded surfaces like twisted fabric or the skin of a sleeping animal. Walking across it, you find surfaces that look like they were stirred with a great slow spoon just moments before. In fact, they were stirred just a very long time ago, and very slowly. Lava, pronounced aish-ah, cools into rough, jagged, clinkery surfaces, painful to walk on without good boots. The two Hawaiian words, it said, describe the sound you might make while crossing each type barefoot. The smooth, appreciative sound of pahoho underfoot, and the sharp, unhappy sound of a-aw. Pumice is perhaps the most surprising volcanic rock. It forms when lava cools so rapidly, still full of gas bubbles, that it freezes the bubbles in place and becomes essentially a solid foam. The result is rock light enough to float on water. Imagine that. Rock that floats. After large eruptions, entire rafts of pumice have been found floating across the ocean, sometimes kilometers wide, carried by currents to distant shores. A beach in New Zealand might receive, one quiet morning, a gift of rock from a volcano in the South Pacific. Obsidian is the volcanic rock at the opposite extreme. a smooth, glassy black stone that forms when lava cools so quickly that no crystals have time to grow. It was one of humanity's earliest tools. Its edges can be sharper than surgical steel. For tens of thousands of years, people shaped it into blades and arrowheads and scrapers. Ancient trade routes can be traced by following obsidian artifacts, pieces found far from any volcano, carried by trading hands across deserts and mountains and rivers, evidence of the long human love affair with beautiful, useful stone. You might leave a comment below telling us what you find most restful: the sound of rain, or the image of lava cooling into black stone, or the thought of pumice floating slowly across the wide ocean. We love hearing from you, and it helps us know what stories to bring you next. The smell of an active volcanic area is distinctive, a mix of sulfur and mineral richness that's strangely not unpleasant once you're used to it. The sulfur dioxide released by volcanoes reacts with water vapor and oxygen to form sulfuric acid droplets in the atmosphere. And while that sounds complex, in small amounts it contributes to the formation of clouds, seeding water droplets around tiny particles. Volcanic emissions in this way have a small but real effect on rainfall patterns. The deep earth breathing out, helping to bring rain to the world above. In Iceland, the relationship between people and volcanoes is intimate and everyday. Iceland sits directly on the Mid-Atlantic Ridge, where the Eurasian and North American tectonic plates are slowly pulling apart. New land is born here regularly. The island itself is made almost entirely of volcanic rock, dark and dramatic. And the geothermal heat from below warms homes, heats swimming pools, and generates electricity for the entire country. In Reykjavik, pipes of hot water run beneath the streets and sidewalks, keeping them clear of ice in winter. The earth's warmth flowing gently up through the ground, keeping people comfortable. Icelanders have a word, Eldfell, that means fire mountain. Many of their place names reference volcanoes, lava, heat, as naturally as other cultures name places after rivers or forests. It's a reminder that what feels extraordinary to most of us is, for some people, simply home. The geysers of Yellowstone in the United States are another expression of the same deep heat. Yellowstone sits above one of the most significant hotspots on Earth, a vast reservoir of magma that last had a major eruption about 640,000 years ago. The heat from this system warms groundwater, which rises through cracks in the rock, boiling and pressurizing until it finally bursts upward in the periodic fountain of a geyser. Old Faithful, the most famous geyser in Yellowstone, erupts roughly every 90 minutes, sending a column of hot water and steam perhaps 40 meters into the air, then settling, resting, and beginning to build again. People have been watching it for over 150 years, sitting on wooden benches in all weather, waiting for that reliable release, that beautiful, predictable burst. There's something almost comforting in that dependability. The earth keeping its own schedule, faithful to its own deep rhythms. Let your breath slow to match those rhythms now. In and slowly out. The world around you is very still. You're doing so well, just resting here. Hot springs are perhaps the gentlest expression of geothermal energy. All around the world, in Iceland, Japan, New Zealand, the American West, Turkey, Hungary, water that has seeped underground, been warmed by the Earth's heat, and returned to the surface gathers into pools of still, warm, mineral-rich water. For thousands of years, people have soaked in these pools. The Japanese call the practice onsen, a tradition of bathing in natural hot springs that is both physical and deeply cultural, a practice of slowing down, of surrendering to warmth. The Blue Lagoon in Iceland, with its extraordinary milky blue water, sits amid a field of black lava rock. The vivid color comes from silica and algae in the geothermal water. People float there in the warmth, while steam rises around them, and the Icelandic sky, sometimes pale and silver, sometimes lit with the aurora borealis, stretches above. It's one of those places that feels like it exists at the boundary between worlds. The mineral content of volcanic soils is extraordinary. When lava flows cool and weather over time, they break down into soil rich in phosphorus, potassium, calcium, and other minerals that plants love. Volcanic regions around the world are often extremely fertile. The slopes of Mount Vesuvius in Italy, the volcanic highlands of Central America, the rich red soils of parts of Africa. Farmers in these regions have known for generations that the land is generous. The same process that creates such dramatic changes in the landscape also, in the long patient view, makes the earth more able to feed life. Coffee grown on volcanic slopes in Hawaii, Kona coffee, is famous for its smooth, rich flavor, shaped in part by the mineral character of the soil it grows in. The dark, roasted taste carries in its way something of the earth's own warmth, a cup of something that began, in the long view, as fire. Let that image drift through you softly. Something warm, something that began in the deep earth and found its way over centuries to warmth of a different kind. Volcanic ash, the fine particles thrown into the atmosphere during eruptions, is one of the most far-traveling things in nature. Fine ash particles can be carried by upper atmosphere winds for thousands of kilometers, eventually settling to Earth far from any volcano. After large eruptions, ash has been found in ice cores drilled in Antarctica, in ocean sediments, in ancient soil layers, preserved for thousands of years, a record of what the Earth was doing in distant times. Scientists called volcanologists study these ash layers the way historians read old documents. A layer of ash in a core sample tells them when an eruption occurred, how large it was, even something about the chemical composition of the magma. The Earth keeps its own archive, written in rock and ash and sediment, patient and complete. The year 1816 is sometimes called the year without a summer, a period of unusual cold across the northern hemisphere, caused by the enormous eruption of Mount Tambora in Indonesia the previous year. The ash and sulfur dioxide thrown into the upper atmosphere reflected enough sunlight to lower global temperatures by about 0.5 to 1 degree Celsius. Crops failed across Europe and North America. It was a difficult time for many people. But in that summer in Switzerland, a young woman named Mary Shelley, confined indoors by the cold and gray weather, spent her days writing a story she had dreamed. The story she wrote was Frankenstein, extraordinary that the deep movements of the earth, its exhalations, its slow sighs, rippled outward and touched the imagination of a writer and changed literature forever. There is a particular volcanic phenomenon called lava tubes, channels through which lava flows beneath a hardened outer crust. As the outer surface cools and solidifies, lava continues to flow inside, and when the eruption ends and the lava drains away, it leaves behind a hollow tunnel. These tubes can be enormous. Some are large enough to drive a truck through, stretching for kilometers beneath the surface. When you walk above them, the ground sounds slightly hollow beneath your feet, a subtle reminder of the secret architecture below. Inside lava tubes, the temperature stays stable year-round. In tropical regions, they stay cool. In colder climates, warm. Animals use them: bats, insects, small creatures that appreciate the consistent, sheltered quiet. Some ancient Hawaiian lava tubes contain fresh water pools in their depths, still and dark and perfectly clear. If you're finding this story restful, a like on the video would mean a lot. It lets us know you're here with us and helps other people who need a quiet place to rest find their way to this channel. Volcanic lakes are among the most dramatic and most peaceful natural formations on Earth. Crater Lake in Oregon sits in the collapsed caldera of an ancient volcano called Mount Mazama, which erupted catastrophically about 7,700 years ago. What remained was a vast, deep bowl that gradually filled with rain and snowmelt over centuries, becoming one of the deepest and clearest lakes in the world. The water is an extraordinary shade of deep blue, a blue so vivid and so deep it seems almost unreal. There are no rivers flowing into Crater Lake. Its water is almost entirely rain and snow filtered through volcanic rock, extraordinarily pure. Scientists have measured its clarity. Objects are visible at depths of up to 40 meters. On calm days, the reflections in its surface are so precise that you might struggle to find the boundary between water and sky. Everything doubled, everything quiet. The word caldera comes from the Spanish for cauldron, a large pot. It forms when a volcano's magma chamber empties so completely, so quickly, that the structure above collapses inward, leaving a great sunken bowl. Some calderas are small, some are vast. The Yellowstone caldera stretches roughly 55 by 72 kilometers across. The entire valley you might drive through, with its forests and rivers and bison grazing in the meadows, sits inside an ancient collapsed volcano. There are places in Japan where volcanic gases seep up through cracks in the ground in regions called Jigoku. The word means hells in Japanese, but they are visited as tourist attractions, places of wonder rather than fear. Pools of bubbling mud vents of steam, water of extraordinary colors, turquoise, orange, blood red, each colored by different mineral contents. The red is from iron, the blue from silica, the orange from sulfur, the earth painting with its own palette in its own time. Let those colors drift past behind your eyelids. Turquoise, deep blue, the warm orange of something glowing very far away. You are very comfortable, very still. The relationship between volcanoes and climate is long and complex and genuinely fascinating when you approach it with patience. Large eruptions inject sulfur dioxide into the stratosphere, where it reacts to form tiny droplets of sulfuric acid that reflect sunlight back into space. The result, historically, has been a measurable cooling of the Earth's surface, sometimes by a fraction of a degree, sometimes more, for a year or two after a significant eruption. But over very long geological timescales, volcanoes have also been a source of warming. The carbon dioxide they release is a greenhouse gas, and over millions of years, volcanic outgassing has contributed to the warmth of the Earth's atmosphere. It's a balance, the deep planet breathing out, the atmosphere absorbing, life adapting and adjusting. The Earth's climate over billions of years is partly a conversation between volcanoes and oceans and atmosphere and life itself. A very long, very slow conversation, happening at timescales that make the entirety of human history feel like a single afternoon. There are regions of the ocean floor where vast amounts of lava erupted in ancient times, not from single volcanoes, but from enormous cracks in the ocean crust, creating what geologists call large igneous provinces. These events, some of the largest in Earth's history, happened very slowly by human standards, but catastrophically by geological ones, perhaps over 1 million years. The Deccan traps in India, the Siberian traps in Russia, enormous flood basalt regions formed by these events, covering hundreds of thousands of square kilometers with layered lava. The Siberian traps eruptions about 252 million years ago coincided with the largest mass extinction in Earth's history, the Great Dying, when perhaps 90% of all species on Earth went extinct. The gases released over hundreds of thousands of years, carbon dioxide, sulfur dioxide, methane, changed the climate and ocean chemistry in ways that most life couldn't survive. It is one of the most sobering events in the geological record. And yet, from it, the survivors, those small and adaptable few, eventually diversified into new forms, filling the emptied ecological niches, evolving into the extraordinary diversity of life we see today. Destruction and renewal on a timescale so vast it becomes something almost like a natural rhythm. The dinosaurs evolved after that extinction. Mammals evolved. Eventually, very recently, humans. We are here partly because of what the Earth released 250 million years ago in its slowest and most patient breathing. Rest in that thought for a moment. How long the chain of events is that leads to you, here, now, comfortable and warm, and breathing quietly. How many unlikely turnings, how much patience the world has had, building toward this. The mineral olivine, a beautiful pale green stone, sometimes gem quality, called peridot, is one of the most common minerals in the Earth's mantle and in volcanic rocks. On the big island of Hawaii, there's a beach called Papakolea, one of only 4 green sand beaches in the world. Its sand is made of olivine crystals eroded from the surrounding volcanic cliffs. A beach that is literally green. You walk on it, and the sand glitters faintly, and every grain was once deep in the earth, part of the great warm interior, brought to the surface by lava, and then shaped by waves into something you can walk on, sit on, hold in your hand. Do check out the playlist if you haven't already. There are stories about forests waking up at dawn, about rain on still water, about the very slow lives of ancient stones, all waiting for you whenever you need them. The idea of a supervolcano sounds dramatic, but like most things in nature, it's really just a matter of scale. A supervolcano is simply a volcano capable of producing an eruption of extraordinary magnitude, one that ejects more than 1,000 cubic kilometers of material. Yellowstone is one. Lake Toba in Sumatra is another, and its eruption about 74,000 years ago was the largest in the last 25 million years, sending ash across a vast region. After the Toba eruption, the Earth entered a volcanic winter that may have lasted years. Some researchers have proposed that the human population at that time was severely reduced, perhaps to a few tens of thousands of individuals worldwide, creating what geneticists call a bottleneck in human evolution. Whether or not this is precisely true is still debated, but the thought is quietly remarkable that we, all 7 billion plus of us, might carry in our genes the echo of those difficult years, that every human alive today might descend from the small, resilient community that survived and stayed warm and found food and kept going. We are, in some sense, children of that cold, children of that winter. And here we are. The Ring of Fire includes some of the most famous volcanoes in history. Krakatau, in the strait between Java and Sumatra, whose 1883 eruption was heard nearly 5,000 kilometers away. Reportedly, the loudest sound in recorded human history. The sound wave traveled around the Earth multiple times. Barometers in distant countries rose and fell as the pressure wave passed. It is difficult to imagine a sound that large, a sound that wraps around the whole world. Pinatubo in the Philippines, which erupted in 1991 after being dormant for over 600 years. Scientists had been monitoring it and evacuated hundreds of thousands of people in the days before the eruption. One of the most successful evacuation efforts in the history of volcanology. The eruption was the second largest of the 20th century, sending ash 40 kilometers into the sky. For 2 years afterward, global temperatures dropped measurably. Aircraft avoiding the ash cloud had to be rerouted around the world. And yet, within months of the eruption cooling, life was returning to the volcanic slopes. Plants colonizing the ash, birds following insects. The slow, patient return of the green world. Let your body relax just a little more. Shoulders, hands, the space between your eyebrows. You're so comfortable right now, just drifting. The volcanologist's job is one of the most patient in science. It involves waiting, watching, measuring small changes. The ground around a volcano often swells slightly before an eruption as magma moves upward. Instruments called tilt meters and GPS stations measure this swelling millimeter by millimeter. The frequency and character of small earthquakes changes as magma moves through rock, and seismometers record these changes in sensitive detail. The chemical composition of gases emerging from the volcano shifts in the weeks and months before activity increases. It is detective work done on geological time, reading the Earth's subtle signals, learning to hear what it's saying before it speaks loudly. Some of the world's most important volcanological research stations are in remote places, perched on the edges of calderas, built on hardened lava fields, maintained through difficult weather and difficult access. The scientists who work there develop a deep familiarity with their particular volcano. They learn its rhythms the way you might learn the rhythms of a place you've lived in a long time, which sounds are ordinary, which are unusual, what the light looks like at different times of day, when the gases tend to increase. There's something beautiful about that kind of attention, that deep, patient looking, watching a mountain the way you might watch a sleeping thing, listening for the change in its breathing. Mount Etna on the island of Sicily in southern Italy is one of the world's most active volcanoes and has been erupting regularly for at least 500,000 years. The ancient Greeks believed it was the forge of Hephaestus, their god of fire and craftsmanship. They believed the one-eyed giant Polyphemus lived in its caves. The smoke rising from its summit was to them the breath of something enormous and divine living inside the mountain. Etna erupts frequently, sometimes dramatically, with lava fountains and ash clouds, sometimes gently, with slow lava flows down its flanks. Towns and farms exist on its slopes, some of which have been destroyed and rebuilt multiple times over centuries as lava flows have reached them. The people of Sicily have lived alongside Etna for so long that it's simply part of life, present on the horizon, occasionally active, occasionally spectacular, but mostly just there, part of home. The fertility of Etna's volcanic soil has made it one of the most agriculturally productive regions in Italy. Vineyards grow on its slopes, and the wines they produce are distinctive, flavored by the minerals in the volcanic soil, by the altitude and the particular character of the place. To taste them is, in a small way, to taste the mountain. Lava that reaches the ocean creates something called laze, a hazy, mildly acidic steam formed when hot lava contacts seawater. It rises in white plumes from the coastline, drifting out to sea. Standing nearby, you would smell something faintly sharp and mineral. But from a distance, the sight of it, the black lava meeting the blue water, the white steam rising, has a quiet, elemental beauty. Two ancient forces meeting at the edge of the world. If you've enjoyed tonight's story, we'd love it if you left a comment, even just a word or two. It means so much to us to know you're here, resting and breathing along with these stories. Where lava enters the ocean and cools rapidly, it sometimes forms structures called pillow basalts, rounded bulbous shapes stacked and tumbled over each other, looking exactly like giant pillows of dark stone. The ocean floor is covered with them in volcanic regions. Deep-sea robots exploring the mid-ocean ridges have filmed fields of pillow basalts stretching as far as their lights can reach. A dark, quiet landscape of stone pillows draped across the seafloor in the permanent night of the deep ocean. New land is being made there in that darkness. The earth still building, still patient, still adding. Iceland's newest island, Surtsey, rose from the ocean in a series of eruptions between 1963 and 1967. When the eruptions ended, scientists were given a unique opportunity to watch in real time how life colonizes entirely new land. They designated Surtsey a nature reserve and have been observing it ever since. Within a few years of the eruptions, seabirds began visiting the island. Their droppings brought seeds and fertilized the barren lava. Bacteria arrived, carried by wind and sea. Then plants, first mosses and hardy grasses, then wildflowers. Earthworms were found in the 1990s. More complex plant communities followed. It is a living experiment in how the world rebuilds itself, how life, given bare rock and time and a little warmth, finds its way, starts small, grows patient and persistent, fills the emptiness with something green and alive. There are places in the world where volcanic activity has created landscapes so unusual, so otherworldly, that they seem to belong to a dream. The Dalal Depression in Ethiopia, one of the lowest, hottest places on Earth, sits in a region of active volcanism and hydrothermal activity that has created pools of acid and salt formations in colors that seem impossible. Yellow and green and white and orange arranged in crystalline terraces and chimneys. Almost no life survives in the pools themselves. The conditions are too extreme, but the colors are extraordinary. The Cave of Crystals in Chihuahua, Mexico, sits in a volcanic region where hot, mineral-rich water once flooded a natural cavern for hundreds of thousands of years. In that warm, still water, selenite crystals grew, enormous ones. The largest on record is over 11 meters long. Imagine a room the size of a large building filled with crystals larger than trees, translucent and pale, glowing softly in any light you brought to them. Geologists who enter the cave must wear special suits to survive the heat. Temperatures inside reach up to 58 degrees Celsius. The crystals formed in total silence, total patience, over 500,000 years. Let your mind rest on the image of that cave, the pale crystals, the warm air, the perfect, deep quiet. Mount Erebus in Antarctica is one of the southernmost active volcanoes on Earth. It sits on Ross Island, near scientific research stations, and has been continuously erupting for at least 1.3 million years, making it one of the longest continuously active volcanoes known. In its crater is a lava lake, a permanent, persistent pool of molten rock that glows at night, visible to researchers working at nearby stations. They can look up from the ice and snow of Antarctica and see at the top of that dark cone a soft orange glow. Lava on ice, ancient fire in one of the coldest places on Earth. The world is full of these extraordinary juxtapositions, and they make it more beautiful. Scientists at research stations near Erebus have discovered that some of its fumaroles, vents of steam and gas, create natural ice towers and caves around themselves in the Antarctic cold. The warm, moist air from the volcano rises through cracks in the ice, warming and carving hollow chambers. Inside these chambers, the temperature is above freezing, and microbial life has been found living there. Unique communities of heat-loving bacteria and algae clustered around the volcano's warmth beneath the ice. An underground world of warmth hidden under the frozen surface of the coldest continent. Life, again, finding warmth, finding a way. The sounds of a volcano, for those who study them carefully, are a rich and varied language. Beyond the obvious rumbles and booms, sensitive instruments detect infrasound, low-frequency sound waves below the range of human hearing. These travel enormous distances through rock and air and can be detected thousands of kilometers from their source. There are also acoustic signals in the audible range, the hissing of fumaroles, the bubbling of lava, the deep harmonic tremor that sometimes precedes an eruption, like a low hum felt more in the body than heard with the ears. Researchers have even created musical pieces from volcanic data, translating seismic readings into sound, slowing down or speeding up the signals until they fall within human hearing range. The result is strange and beautiful, something between music and geology. The Earth translated. Diamonds reach us from deep within the Earth through volcanic pathways called kimberlite pipes, narrow columns of rock that were once conduits for a particularly deep-sourced magma. Kimberlite eruptions happen rarely now, but throughout Earth's history, they brought material from as far as 150 kilometers below the surface, from the lithospheric mantle, up through the crust and onto the surface. Diamonds form at those extraordinary depths, under pressures that carbon cannot escape in any form but crystal. Then the kimberlite eruption carried them upward quickly, much more quickly than most volcanic processes, and preserved them in the cooled rock where they have been found, patiently waiting for millions of years. Every diamond you have ever seen made a journey from deep inside the earth, formed under pressure and heat in the dark over billions of years, and then carried upward in a rush of ancient rock to the surface. Patient, brilliant, compressed. The Hawaiian Islands, as you drift southward from Kauai to the Big Island, tell a story of time. Kauai, the oldest of the main islands, is deeply eroded, its volcanic rock worn into spectacular cliffs and valleys and ridges. Oahu is younger, Maui younger still, and the Big Island youngest of all, still actively growing at its southeastern edge as Kilauea continues to add new land. To the southeast of the Big Island, beneath the ocean, a new seamount called Loihi is slowly building. In perhaps 10,000 to 100,000 years, it will break the ocean surface and become the newest Hawaiian island. Already, in the depths, it is growing. The earth is still making islands, still patient, still building. Please do take a moment, if you feel like it, to explore the playlist. There are stories about ancient forests, about the way rivers find the sea, about the patient lives of stones, all there, all soft and quiet, whenever you need them. The word magma comes from the ancient Greek for a thick unguent, or kneaded mass, something thick and worked with the hands. There's something almost domestic about that origin. The ancient word doesn't reach for drama or power. It reaches for texture, for the feel of something warm and workable. The earth's inner warmth described the way you might describe bread dough or wet clay. Volcanoes have created some of the most remarkable and most visited landscapes on Earth. The Cappadocia region of Turkey, with its extraordinary fairy chimneys, tall columns of soft volcanic tuff topped with harder rock that resisted erosion while the softer rock around them wore away. People carved homes and churches and entire underground cities into these columns thousands of years ago. They found that the volcanic rock once cut was warm in winter and cool in summer, regulating temperature naturally. The deep Earth's warmth diffused and moderated into something livable. From above, in a hot air balloon at dawn, the sun just rising, the sky pale gold, the columns throwing long shadows, Cappadocia looks like a landscape from a gentle dream. You float above it, barely moving, and the whole surreal wonder of it spreads below you in the early light. Let that image float with you now. The balloon, the gentle dawn, the warm rock below, the sky opening ahead. The word lava comes to us through Italian, and before that, perhaps from the Latin for to wash, because lava flows down slopes the way water does, washing over everything in its path in slow, patient waves. When it cools, it leaves behind something new, a new surface, a new beginning for the landscape. In New Zealand's North Island, the Wairakoi geothermal field was one of the first places in the world to generate electricity from geothermal power, beginning in 1958. Hot water and steam from underground are used to drive turbines, producing electricity cleanly and reliably. Iceland generates almost all of its electricity from geothermal and hydroelectric sources. The Philippines, Kenya, and several other countries generate significant portions of their power from the Earth's own warmth, the deep heat of the planet. The same heat that drives volcanoes and shapes landscapes and creates diamonds is also quietly powering homes and hospitals and schools in multiple countries around the world. The Earth giving back, sharing its warmth with the surface in the most practical and useful way. In Japan, a country shaped profoundly by its volcanic geology, there are over 3,000 hot spring resorts. Onsen. The culture around them is ancient and exquisite. You soak in the naturally warm water, surrounded by wooden screens or stone gardens or forested hillsides, and you let the warmth work through you. The mineral content of each spring is different, some high in sodium, some in sulfur, some in iron. Different springs are said to have different beneficial qualities, and while specific medical claims vary, the general wisdom is simple: warm water, quiet surroundings, time to rest. The body responds to this the way it always has. It softens, it lets go. Let yourself do that now, if you can. Just a little more letting go. Your body knows how to rest. You don't need to do anything. The Azores, a group of Portuguese islands in the middle of the Atlantic Ocean, sit directly on the mid-Atlantic ridge. They are volcanic islands in an active geothermal region, and the landscape shows it. Hot springs, fumaroles, green crater lakes, black sand beaches. One lake on the island of Terceira, Lagoa das Furnas, has volcanic vents on its floor, and locals have been cooking food by burying pots in the geothermally heated ground nearby for generations. A stew lowered into the earth in the morning and left through the day, cooked by the patient warmth below, ready by evening. Food prepared by a volcano, something warm and nourishing from the deep earth. The relationship between volcanoes and human civilization is complex and ancient. We have feared them, worshipped them, studied them, built our greatest cities near them because their soil is so fertile and their water is often so warm and pure. We have lost cities to them, most famously Pompeii and Herculaneum, buried by the eruption of Mount Vesuvius in 79 AD in a matter of hours. Those cities, preserved in volcanic ash, have given archaeologists an extraordinary window into Roman life. The bread still in the ovens, the graffiti still on the walls, the everyday life of people frozen in an extraordinary moment of the Earth's history. Pompeii, buried under several meters of ash and pumice, lay largely forgotten for over 1,600 years. When excavations began in the 18th century, the preserved world that emerged was remarkable. Not just the buildings and streets, the details, loaves of bread, jars of wine, a dog curled on a mosaic floor, garden walls still bearing traces of their original paint in colors of ochre and red and deep blue. The sounds and smells of that August day in 79 AD are beyond recovery, but the physical world was preserved with startling completeness. In the ash, hollow spaces remained where organic materials, wooden furniture, fabric, bodies, had decomposed. Archaeologists realized they could inject plaster into these hollows and recover the shapes. The shape of a wooden bed, the shape of a wooden door, still slightly open. The shapes of people, preserved in their final postures, going about an ordinary morning before it became something else entirely. It is sobering, and in its way, it is also something that invites reflection on the long conversation between the earth and the people who live on it, on all that has been built and buried and built again, on the patience of the earth and the patience of the people who keep returning, keep building, keep planting gardens in the fertile volcanic soil. there is a kind of resilience in that returning, a kind of quiet courage in planting a garden on a volcano's slope, knowing what you know, trusting the ordinary days to continue, which they almost always do. Let that thought be gentle in your mind. Ordinary days continuing, gardens growing. The sulfur vents called fumaroles emit water vapor and various sulfur compounds, and around them, over time, vivid mineral deposits build up. Yellow sulfur crystals form delicate incrustations around vent openings. White sulfate minerals deposit in terraced layers. The colors look like something painted deliberately. Vivid yellows and whites against the dark volcanic rock. Close up, under a hand lens, the crystals are intricate and geometric, grown slowly in the breath of the earth. Mount Shasta in Northern California, a large stratovolcano in the Cascade Range, has been sacred to multiple indigenous peoples for thousands of years. The Shasta, Karuk, Wintu, and other groups have stories and traditions connected to the mountain. It is a place of spiritual significance, of ceremony, of connection to the deep time and the living land. The mountain rises over 4,000 meters above sea level, nearly always snow-capped, visible from great distances across the surrounding plateau. Many cultures around the world have recognized volcanoes as sacred, as places where the boundary between the ordinary world and something deeper is thinner. Whether you approach that metaphorically or literally or simply as poetry, there's something right about it. Volcanoes are places where the interior of the earth becomes visible, where the hidden becomes apparent, where something that has been building in the dark, patient and warm and pressurized, finally finds its way to the surface. There's something very human in that recognition. The sense that the places where deep things emerge are holy. The soil that forms from weathered volcanic rock is called andesol, and it covers about 1% of the Earth's ice-free land surface, but it produces a disproportionately large share of the world's food. The volcanic highlands of Central America grow much of the world's best coffee. The rice paddies of Java grow in volcanic soil so rich that the island has sustained one of the densest agricultural populations on Earth for thousands of years. Volcanic soil in East Africa supports forests and tea plantations and some of the most diverse plant communities on the continent. The same forces that change landscapes dramatically also in the long aftermath make those landscapes extraordinarily generous. There's a type of volcanic rock called komatiite that is found mostly in very ancient geological formations, rock that formed over 2.5 billion years ago, when the Earth's mantle was significantly hotter than it is today. Komatiite lava was so hot and fluid that it erupted at temperatures of perhaps 1,600 degrees Celsius, far hotter than any modern lava. It flowed in thin, fast-moving sheets across the ancient Earth. The rock it left behind has a distinctive texture, long-bladed crystals called spinifex texture, that geologists recognize immediately. To find it is to hold a piece of the very young Earth when the fires inside burned brighter. The deep sea volcanic vents, hydrothermal vents, may have been the birthplace of life itself. The hypothesis, now taken seriously by many scientists, suggests that the combination of chemical energy, mineral gradients, and warm enclosed spaces near hydrothermal vents created conditions uniquely suited for the first simple chemical processes that eventually became life. The warm, mineral-rich water, the chemical gradients between different temperatures, the porous rock full of tiny chambers where chemistry could happen, sheltered from the cold and the currents. If this is true, if life began in the warmth of the Earth's own exhaled heat, then every living thing on this planet, every tree and fish and bird and person, carries in their deep cellular history a memory of volcanic warmth, of the Earth's breath, of the patient chemistry of the deep, hot dark. You and volcanoes are not as separate as they might seem. Please feel free to share this video with someone who could use a quiet hour tonight. And if you haven't yet, the playlist is there, a whole library of quiet stories, waiting for whenever you need them. The Canary Islands off the coast of Northwest Africa are volcanic islands, still volcanically active. In 2021, the Cumbre Vieja volcano on La Palma erupted after 50 years of quiet, and for 85 days, lava flowed slowly toward the sea, adding new land to the island's western coast. Scientists and cameras documented the event in remarkable detail. The slow orange rivers, the steam at the ocean's edge, the extraordinary solidified shapes where lava had cooled in the sea. When it was over, La Palma was measurably larger than before. New coastline, new rock, new beginning. The people of La Palma, displaced from their homes by the lava, began to return and rebuild as soon as it was safe. Some found their houses buried under meters of black rock. Some found them unharmed, lava having flowed around them. Either way, they began again. The earth had added to the island. Life was continuing. The patterns that form when lava cools can be astonishing. When lava cools evenly and slowly, it can contract into regular shapes. Most famously, the hexagonal columns of basalt seen at places like the Giant's Causeway in Northern Ireland and Fingal's Cave in Scotland. These six-sided columns form through the same process that creates cracks in drying mud, or the cells in a honeycomb. The physics of contraction finding the most efficient arrangement in 2 dimensions. Nature solving a geometry problem over and over, producing the same beautiful answer. The Giant's Causeway was formed about 60 million years ago during a period of intense volcanic activity. Its columns rise from the sea and continue into the water, some perfect hexagons, some with 4 or 5 or 7 sides. Near perfect, close enough to make you understand the underlying order even in the variations. An ancient Irish legend says the causeway was built by the giant Fionn Barra to walk across to Scotland. In Scotland, the same rock appears at Fingal's Cave, the other end of that ancient mythological bridge. In the silence of early morning, before the visitors arrive, the Giant's Causeway just sits there, the dark columns catching the first gray light off the sea, the water moving quietly over the lower stones, the wind soft and salt-edged, the whole ancient place just breathing. Let that image be with you. The gray morning light, the dark columns, the quiet sea. The word tephra refers to all the material thrown into the air during a volcanic eruption, from the finest ash to the largest rocks, called volcanic bombs, that arc through the air and cool into streamlined shapes as they fly. The smallest tephra particles, the ash, can remain suspended in the atmosphere for years. The largest volcanic bombs, occasionally hundreds of kilograms, follow ballistic paths and land nearby, sometimes still glowing inside. Volcanic ash, so fine that individual particles are invisible to the naked eye, can travel the world. After the 2010 eruption of Eyjafjallajökull in Iceland, a name that became briefly famous and largely unsuccessfully pronounced across global media, ash clouds drifted across Europe and grounded flights for days. The invisible product of a fire in Iceland, floating above France and Germany and the UK, reminding people that the atmosphere is continuous, that the Earth's activities are not local, but planetary. What's remarkable about that eruption, in retrospect, is that it was relatively small by volcanic standards. The world-spanning effects came from fine ash carried by upper winds, the Earth's breath reaching everywhere. There is a particularly peaceful kind of volcanic landscape found in regions that were glaciated during the last ice age. In Iceland, Canada, and parts of Scandinavia, ancient lava flows were overridden by glaciers thousands of meters thick. The glaciers shaped and polished the volcanic rock into smooth, rounded forms, scoured away the rough edges, filled valleys with glacial sediment, left behind landscapes of extraordinary soft beauty. Dark volcanic rock, rounded and smoothed, reflecting still lakes, draped in moss that grows soft and thick and extraordinarily green. In Iceland, this landscape is called Heidi, the highlands, and in summer it is carpeted in Arctic flowers and threaded with streams so clear they seem invisible, and the light at that latitude is soft and long and never quite dark. You could walk there for hours in a kind of gentle, spacious quiet. You are resting now, really resting. The room is quiet, and your breathing has slowed, and the stories we've been telling tonight have drifted through you like the gentlest of breezes, warm, soft, carrying something good. The earth beneath you is old beyond imagining. It has been building and releasing and cooling and building again for 4.5 billion years. Its volcanoes have made islands and mountains and soil and the very air you're breathing. They've sparked life and sculpted coastlines and given glaciers something to work with. They've sent particles into the upper air that painted extraordinary sunsets for people who stood outside, not knowing why the sky was so beautiful, and felt grateful anyway. The magma in the deep chambers moves so slowly that entire human civilizations rise and fall in the time it takes a column of rock to shift a few kilometers. The earth is patient in ways that are almost incomprehensible, and in its patience, It has made everything. Every grain of sand was once part of a mountain. Every mountain was once part of something deeper. Every bit of land you've ever walked on was formed from the deep interior of the planet, shaped by heat and time and the slow, constant turning of the plates. You are part of this. You, resting here now. The atoms in your body were forged in stars and built into the earth and cycled through rocks and soils and oceans and living things across billions of years before finding their way into the arrangement that is you, breathing quietly in this room, ready to sleep. The earth is still making volcanoes, still adding new land at the ocean ridges, still breathing through its fumaroles and geysers and hot springs, still sending warmth upward through the crust in the form of lava that cools into pillow basalts in the dark of the deep sea, and obsidian on the floors of ancient calderas, and soil on volcanic slopes where coffee grows and grapes grow and wildflowers grow in the spring. All of it, always, moving slowly, patient, warm at its heart. And you can rest in that warmth now. The warmth of the world beneath you, the warmth of your blankets and your room, the warmth of knowing that the earth has been doing this for longer than you can imagine and will continue long after this quiet night is over. You are held in something ancient and large and in its way very gentle. Let your eyes close if they aren't already. Let the images from tonight drift through the space behind your eyelids. The glow of a lava lake seen from a research station in Antarctica, the green sand of a Hawaiian beach, the pale crystals growing in a warm, dark cavern over 500,000 years of perfect silence, the columns at the Giant's Causeway catching the first soft light of morning. Let the sound of steam rising from a fumarole in Iceland be the last sound you hear tonight. Barely audible, warm, rising gently into cold, clean air, rising and drifting, dispersing, gone. You have been such good company tonight. Thank you for resting here with us. If you'd like to leave a quiet comment before you sleep, we'd love to read it in the morning. And if you want more, the playlist is there, full of slow and gentle stories, waiting for whenever you come back. The earth is still here, still warm, still breathing. And so are you. Let's stay a little longer in this quiet space together, drifting through the slow and patient world of what lies beneath. There is something called a volcanic arc, a curved chain of volcanoes that forms above a subducting plate. When one tectonic plate dives beneath another, it carries with it seawater trapped in ocean sediments and in the rock itself. As that plate descends deeper into the hot mantle, the water is released, and water, remarkably, lowers the melting point of rock. It helps the rock above the descending plate begin to melt, forming magma that then rises through the overlying plate and emerges as a chain of volcanoes. The curve of the arc reflects the curve of the subduction zone below. The Aleutian Islands of Alaska form one of the most dramatic volcanic arcs on Earth, a long necklace of volcanic islands curving out into the North Pacific, many of them remote and rarely visited, where volcanoes erupt into cold, gray, fog-draped air with nobody watching but the seabirds. There is something particularly beautiful about that. A volcano erupting in a place where no human eye is present. Just the sound and the heat and the birds lifting from the cliffs. Japan's volcanic geography is so defining that the country has a specific cultural relationship with hot springs, with mountains, with the particular quality of volcanic soil. The island of Kyushu has dense geothermal activity, and the city of Beppu is famous for its 8 famous geothermal areas, pools, and vents called hells in the local language, each one different in color and temperature and behavior. One is a vivid blood red from iron content. One is a clear cobalt blue. One has mud that bubbles gently and slowly, the gray surface rising and falling with each release of steam from below in a rhythm so steady and so slow, it's almost like breathing. You can sit beside these pools and simply watch. The bubbling, the color, the steam rising and dispersing. People have sat beside them for centuries doing exactly this, finding something restful in the evidence of the Earth's own slow process. Volcanoes on the ocean floor, away from any plate boundary, sometimes form chains called seamount chains. As a tectonic plate moves slowly over a fixed hotspot, the hotspot punches through the plate again and again, each new volcano forming slightly further along as the plate moves. Over millions of years, this creates a line of seamounts, underwater mountains, like stitches made by a slow and patient needle through moving fabric. The Hawaiian Emperor's Seamount Chain stretches thousands of kilometers northwest from the current Hawaiian Islands. A long trail of extinct underwater volcanoes marking the path the Pacific Plate has taken over the hotspot. The oldest seamounts at the far end of the chain are over 80 million years old. 80 million years of a plate moving and the Earth keeping the record. Every seamount a memory. Let your breathing slow just slightly more. There's nothing to do, nothing to think about too carefully. Just these soft images drifting. The phenomenon of volcanic tremor is one of the most quietly beautiful things in volcanology. Unlike the sharp, distinct signal of an individual earthquake, volcanic tremor is a continuous, sustained vibration, a hum, essentially, deep in the earth. It can last for hours or days and is caused by the movement of fluids, magma, water, gas, through cracks and conduits in the volcanic system. If you could hear it, which you can't directly, as much of it is infrasound, it would sound something like a very deep, very soft, continuous note. The earth humming to itself, quietly working through something. A sound below sound, felt rather than heard. Researchers have translated volcanic tremor into audible frequencies and played it back. It has been described as haunting, resonant, strangely calming, something in the way a continuous tone can be calming. It establishes a ground note, a foundation, something steady beneath the more variable signals of daily life. The earth, humming, steady, warm. There are volcanic mountains so high that they rise above most of the atmosphere's weather. At the summit of Mauna Kea in Hawaii, which is measured from its base on the ocean floor, the tallest mountain on Earth, the air is so thin and dry and clear that it has become home to some of the world's most powerful astronomical observatories. The summit sits above about 40% of the Earth's atmosphere and nearly all of its water vapor. On clear nights, the seeing is extraordinary. The stars are sharp and still. The Milky Way stretches across the sky in a band of light so dense it looks almost solid. To stand there at nearly 4,300 meters above sea level on a mountain made of cooled lava from the deep earth and look up at stars, it is one of those experiences that places you very precisely in the universe. Below you, the deep, warm mantle. Above you, the stars. And you, in between, in the thin, clear air of a volcanic summit, breathing slowly. When scientists drill into volcanic rock to extract core samples, they sometimes find something surprising embedded in the rock. Tiny magnetic minerals that have preserved a record of the direction of the Earth's magnetic field at the time the lava cooled. Because molten lava destroys all magnetic alignment, and then, as the rock cools and solidifies, magnetic minerals lock into alignment with whatever direction the field is pointing at that moment. Each lava flow becomes a kind of fossil compass. Through this record, geologists have discovered something remarkable. The Earth's magnetic poles reverse periodically. North becomes south, south becomes north. It has happened hundreds of times in Earth's history. The last reversal was roughly 780,000 years ago. The reversals happen gradually over thousands of years, and the magnetic field doesn't disappear. It just weakens and wanders and eventually settles in a new orientation. The volcanic rock record has revealed this magnetic history with extraordinary completeness, especially along the mid-ocean ridges where new seafloor is constantly forming. The alternating stripes of normal and reversed magnetic polarity in the seafloor rock on either side of the ridge were one of the key pieces of evidence that confirmed the theory of plate tectonics in the 1960s. The Earth keeping its own magnetic diary in the rock. Everything has its record. Everything leaves a trace. The cooling of lava, the fall of ash, the growth of a crystal in a warm, dark cave, the movement of a plate over a hot spot, long, patient records written in stone. The ancient Romans understood a practical use for volcanic material very early. They discovered that mixing volcanic ash from the region around Pozzuoli, a town near Naples, with lime created a concrete that was extraordinarily durable. Modern analysis has found that this Roman concrete, called opus caementicium, actually becomes stronger over time as mineral reactions continue within it. Roman harbors built with this volcanic concrete have lasted 2,000 years in saltwater, while modern concrete in marine environments typically begins to degrade within decades. Volcanic ash in the harbors of ancient Rome, quietly and patiently continuing to cure. The Pantheon in Rome, that extraordinary domed temple built nearly 2,000 years ago, still standing, still visited, still remarkable, is built with volcanic concrete. The dome itself, at over 43 meters in diameter, was the largest in the world for over 1,000 years. It was made from a volcanic aggregate called pozzolana, and it has been there through all the centuries, through earthquakes and floods, and the collapse and rebuilding of the city around it, patient and solid. A building made of volcanic material standing in the center of a city, housing the ordinary afternoons of ordinary visitors. Coffee drunk nearby, conversations had beneath its ancient walls, pigeons resting on its stones in the afternoon sun. The deep earth present in the middle of daily life. Take a slow breath now. Imagine that afternoon sun on old stone, the warmth of it, the deep quiet inside that ancient space. Volcanic islands have extraordinary rates of species endemism, species found nowhere else on Earth. Because islands are isolated by water, species that arrive must adapt to local conditions without the influence of mainland relatives. Over thousands of generations, they become new species shaped by the volcanic landscape and climate of their particular island. Hawaii has the highest rate of endemism of any island group in the world. Over 90% of its native species are found nowhere else. The silver sword plant, a remarkable Hawaiian native, grows on the slopes of Haleakala volcano on Maui at high altitude in thin volcanic soil in conditions of intense solar radiation and great cold at night. It grows slowly for up to 50 years, a silver rosette of narrow leaves that reflect the harsh light. Then, once in its lifetime, it sends up a single tall flower stalk covered in hundreds of blossoms, and after that, flowering. After all those decades of patient growing, it dies. The whole of its long life building toward that single flowering, patient beyond anything we can easily imagine. There is something deeply moving about the silver sword. All those years of slow and quiet growing, the thin volcanic soil, the high cold air, and then, once, the extraordinary flowering. Deep beneath Yellowstone, the magma system is monitored by hundreds of instruments, seismometers, GPS stations, tilt meters, gas sensors. Scientists at the Yellowstone Volcano Observatory watch the data continuously. The ground at Yellowstone rises and falls by centimeters over the years, breathing, in a sense, with the pressures and movements of the magma and hydrothermal system below. The caldera has been rising slightly for periods, then settling, then rising again. This monitoring is careful, patient, ongoing science, the kind that requires commitment over decades. Researchers who began their careers watching Yellowstone have retired and been replaced by new scientists who continue watching the same instruments, the same readings, the same slow drift of data that tells the story of what the deep system is doing. Most of what it is doing, most of the time, is resting, breathing, maintaining its hydrothermal circulation, sending warm water through cracks to feed the geysers and hot springs. The geysers erupting on their schedules. Old Faithful, every 90 minutes, reliable. There's a kind of reassurance in that reliability, in the fact that even something as powerful as a caldera system can be, for most of its time, simply resting quietly, simply maintaining, simply warm. The volcanic region of Rotorua in New Zealand has been inhabited by Maori people for centuries. The geothermal landscape is woven into Maori culture and tradition. The Maori cooked in natural steam vents, hangi prepared using geothermal heat. Hot springs were used for bathing and healing. The landscape of steaming vents and boiling mud pools and vivid silica terraces was simply the environment of daily life. Extraordinary, sacred, familiar. The Wakarawarawa thermal village in Rotorua is still lived in today. Families cook with geothermal steam. Children have grown up playing near hot springs that their grandparents also played near. The earth's warmth is not a spectacle there. It's home. Some of the most important clues about the deep earth come not from volcanoes themselves, but from the rocks they bring up. Xenoliths, which means foreign rocks. As magma rises rapidly through the mantle and crust, it sometimes picks up fragments of the rock through which it passes. These fragments are brought to the surface intact, preserved within the cooled lava. By studying xenoliths, scientists can examine pieces of the mantle directly. Rock that formed over 100 kilometers below the surface, brought up in the volcanic elevator. Some xenoliths are made of peridotite, the most common rock in the mantle, greenish in color, dense, rich in olivine and pyroxene. Others are made of eclogite, beautiful, dense, dark red and green, formed under the extraordinary pressures of subduction. These rocks have seen depths that no drill has ever reached. They have experienced pressures we can only create briefly in laboratory settings. To hold a xenolith, a piece of the deep earth brought to the surface by a volcano, sitting cool and quiet in a museum collection, is to hold something from somewhere so deep and so old that it resists full comprehension. You can try. You can let the number 100 kilometers, 200 kilometers, pressure of several 100,000 atmospheres move through your mind, and then you let it settle, because some things are too large to fully hold, and they don't need to be held. They can simply be known gently as being there, deep, warm, patient. Let that knowing rest in you softly now. When lava flows into forests, something strange and beautiful can happen. As the lava burns and consumes the trees, the liquid rock can sometimes flow around the outside of a tree trunk and cool there, forming a vertical cylinder of rock around the burning wood. The wood burns away, and what remains is a hollow tree-shaped tube of solid lava, a lava tree mold, sometimes called a lava tree cast. Forests of these molds have been found in Hawaii, standing in cleared lava fields like hollow pillars, each one the exact shape of the tree it surrounded, preserved in black rock, a permanent record of the forest that once stood there. In time, the lava field weathers and breaks down, and new soil forms, and new plants colonize, and eventually a new forest grows where the old one was consumed. And within that new forest, the old lava tree molds stand, the memory of the previous forest enclosed in rock among the living trees of the new one. Life returning, the forest remembering itself. There are volcanic gases that, under the right conditions, form extraordinary deposits around fumarole openings. Sulfur crystallizes from volcanic gases in vivid yellow masses around vent openings, sometimes forming delicate crystal flowers, fragile, asymmetrical, golden yellow, arranged by the geometry of crystal growth around the edges of cracks and openings. Up close, they're intricate and beautiful, cold and delicate in your hand, smelling faintly of something sharp and mineral. The exhaled breath of the earth, crystallized. Native sulfur has been mined from volcanic regions throughout human history. It was used in ancient times for fumigation and bleaching and in religious ritual. The Greeks burned it as a purifier. The Romans used it medicinally. It was one of the 3 ingredients in early gunpowder. Though tonight we leave that particular history aside and stay with the crystal flowers and the fumaroles and the patient chemistry. The island of Volcano itself, the one that gave all volcanoes their name, is a small, dramatic island in the Tyrrhenian Sea, still active, still steaming. Fumaroles on its slopes emit gases that deposit sulfur crystals around their openings. The whole island smells of sulfur, warmly and unmistakably. Visitors come to swim in its sea and soak in its volcanic mud baths, where the fine, warm volcanic mud is scooped over skin and left to dry in the sun before being rinsed in the sea. To float in those warm waters, smelling the faint sulfur on the breeze, feeling the warmth of the earth through the water. It is one of those experiences that puts you in contact with something very old and very fundamental. You are floating above the same forces that have shaped continents and made mountains and sent ash into sunsets that artists tried to capture. All of that, and you floating. Let your body feel that floating now. The warm water, the slow rock, the sky above, very blue, very wide. The most recent fully new volcanic island to emerge above the ocean surface appeared near Tonga in 2014. A small island called Hunga, Tonga, Hunga, Ha'apai. It rose from the sea in a matter of days during an underwater eruption, a pile of dark ash and lava emerging from the waves, steaming and shifting. Scientists watched it carefully, expecting it to erode back into the sea within months. As most new volcanic islands do, their loose ash easily worked away by waves. But it held. The lava that formed its core turned out to be solid enough to resist erosion longer than expected. For years, it sat there, this new island, being colonized by seabirds and small plants, carried by wind and birds. Satellite images showed it slowly greening around its edges. In January 2022, the same volcano erupted massively, one of the largest volcanic eruptions in the century, and the island was mostly destroyed, transformed, reshaped. The eruption sent a pressure wave around the earth. Tonga experienced a tsunami. The sky above the eruption was extraordinary in satellite images, a vast circular cloud of ash and water vapor, perfectly symmetrical, spreading outward at extraordinary speed. The island still exists, in changed form, the earth reorganizing, still patient, still building. The last thing a sleeping mind needs is urgency. So let these final images come slowly, like the last few minutes of a gentle tide coming in. each wave a little quieter than the last, the water barely moving now, the shore very still. There is a place in Oregon called the Lava River Cave, a lava tube that stretches over a kilometer through the dark, formed thousands of years ago when lava drained out of a hardened shell. You enter it through a staircase descending into the earth, and the temperature drops immediately. It's cool inside, a constant few degrees above freezing year-round, because the rock is such a good insulator. You walk by lamplight through the tunnel, the walls smooth in some places and rough in others, the ceiling curving above you. Icicles sometimes hang from the entrance in winter, formed from moisture that freezes in the cold air flowing out of the cave. Deep inside, away from the entrance, the silence is complete. No wind, no birdsong, no traffic or voices, just the soft sound of your own breathing and your footsteps on the uneven volcanic floor. The darkness at the edges of your light is the most absolute darkness, the kind only found underground, where no photon has ever penetrated. You hold your light, and around you in all directions is that ancient, quiet tube formed from something that was once flowing and glowing and hot, now perfectly cool and perfectly still. The deepest borehole ever drilled into the earth is the Kola Super Deep Borehole in Russia, a scientific project that drilled for 20 years, from 1970 to 1994, reaching a depth of 12,262 meters, about 12 kilometers, compared to the radius of the Earth over 6,000 kilometers. It's barely a scratch, a needle prick. But at that depth, the temperature of the rock was nearly 180 degrees Celsius, far hotter than expected. The rock under that pressure had become almost plastic, flowing so slowly it was barely distinguishable from solid. The project was eventually stopped because the drilling equipment couldn't handle the heat. 12 kilometers, and the Earth was already beyond what our best tools could manage. Below that, 4 billion years of undrilled, unsampled, unseen rock, patient, warm, enormous. We will never see most of what the Earth is. We will never drill to the magma chambers that feed the volcanoes we've been talking about. We will never touch the mantle directly. We know it through seismic waves and xenoliths and clever inference, through listening to how the Earth transmits its vibrations, the way you might come to know a neighbor through the sounds that travel through shared walls, gradually, with patience, with the accumulated understanding of many years of paying attention. And there is something lovely in that limit, in knowing that beneath you, right now, is something vast and warm and largely unknowable, not threatening, not frightening, just there, ancient and warm and turning very, very slowly, keeping its own time. Tonight, the volcanoes of the world are doing what they mostly do, resting, or gently steaming, or sending slow orange rivers of lava down dark slopes toward a hissing sea. Katlawia is adding new land. Etna is breathing quietly against the Sicilian sky. Somewhere in the Aleutians, a small eruption is sending a thin plume into cold Pacific air. Old Faithful is building toward its next release. The mid-ocean ridge is spreading millimeter by millimeter in the dark below the Atlantic. And you are here, in your warm room, your breathing slow and steady, the weight of your body soft against the bed. The same atoms that make up the basalt of the ocean floor are in the soil your food grew from, are in the minerals in your blood, are in the walls around you. You are made of the same ancient material as the mountains. You are part of the same long, slow story. You don't need to hold on to anything tonight. The earth is holding you, gently, enormously, without effort. It has been holding things for 4.5 billion years. It knows how. Let the warmth of that be the last thing you feel as you drift. The warmth below, the warmth of your blankets, the warmth of a quiet room at the end of a day that is now gently, softly, completely over. The volcanoes are resting, the deep chambers are still. The crystals in their dark caves are growing so slowly that you will never see them move. And you can be still too now, completely still. Sleep well. The earth is warm, and you are held, and everything is quiet, and there is nowhere to be but here, right now, breathing slowly in the soft dark of a world that has been making itself patiently and beautifully for longer than any mind can hold. Good night.